4.4, using corresponding parts of congruent triangles. Okay, this lesson is going to be called CPCTC, corresponding parts of congruent triangles are congruent. We are going to use triangle congruence, so that's 4.2 and 4.3, and their corresponding parts, which is 4.1, of congruent triangles to prove that their parts are congruent. CPCTC. Here's CPCTC. Corresponding parts of congruent triangles are congruent. And so this lesson is not really anything new. We are going to prove triangles congruent with what we learned in 4.2 and 4.3. SSS, SAS, ASA, and AAS. And then, once your triangles are congruent, once you know that your triangles are congruent, we know that the corresponding parts are going to be congruent as well. That's 4.1. It says if we have congruent polygons, then all corresponding sides and all corresponding angles are congruent. So once we prove them congruent, then we know that all corresponding sides and all corresponding angles are going to be congruent. So this is nothing new. We are just putting together the pieces we've already learned. So let's look at our first problem here. We are given that angle KBC and angle ACB, so let's find KBC right there, and ACB, those are congruent, and angle K and angle A are congruent, so let's mark those. And what are we trying to prove here? We want to prove that segment KB and segment, so this segment right here, and segment AC are also congruent. Now they are not marked. They have no relationship that we can use. I can't stop myself here. We can mark that congruent, right? That's our reflexive property. So we have our blue angles are given, our orange angles are given. We have a side in here that's bireflexive. So now I see angle, angle, side. So I'm thinking we can make these congruent by angle, angle, side. We have two triangles here, and we can make them congruent. We can do triangle, well, it depends on how you go. Let's go KBC. All right, we've got triangle KBC, and I went to one side, so ACB, and that's angle, angle, side. We still don't have any information on those pink sides, but that is what we're after. Well, what are we going to do with this? Now, I told you back when we were looking at the flow proofs that you may want to use them in this section. It doesn't matter. They are simply a two-column proof in a different method. So we need an angle. We said our first angle was given. That's our blue angle. And then we need another angle. That's our second angle. It was given. And we need a side. We use the reflexive property of congruence for that. So we have angle, angle, side. And what that lets us do is make our triangles congruent. We use the angle, angle, side theorem to make our triangles congruent. This is exactly what we did in 4.2 and 4.3. Now, what's new to us here is now once our triangle's congruent, what do we know about those two triangles now? we now know that all corresponding parts are congruent. So we are interested in segment KB and segment CA. Here is segment KB. That wasn't the color I was after. There we go. There is segment KB, and where is segment AC? It's in the same position, right? Position 1 to position 2. So we used our 3 existing pieces, angle, angle, side. We used our 3 existing pieces to make the triangles congruent. Now we know that all 6 pieces are congruent. All 3 angles, all 3 sides, and we should put corresponding in there. So all 3 corresponding angles, all 3 corresponding sides. So what that lets us do is we can say that those 2 segments are congruent because we know that corresponding parts of congruent triangles are congruent. This is CPCTC. Corresponding parts of congruent triangles are congruent. And this is my second favorite to say, CPCTC. We could do this with any of the unmarked sides. We could look up here and we could relate, let me find a different color. We could relate this side, KC and AB. Those are not currently marked. Way back down here. Those are not currently marked. But because our triangles are now congruent, we know those sides are congruent. We have this angle here, right? Angle KCB and angle ABC. Those 2 angles are not marked, but because our triangles are congruent, we know those angles are congruent now. So that's all we are doing, is we are making our triangles congruent so that we can make all of the sides and all of the angles congruent, that we can say that unmarked sides and angles are congruent as well. So let's look at an example of this, and this is one that entertains me quite a bit. Thales was a Greek philosopher, and he developed this method to measure where a ship was out at sea. Because if you've got your archers here on land, or your cannons or whatever, you want to know how far you need to shoot them to protect your bay. And so what he did, let's find a good color here that'll show up, is he stood up on top of a tower. Okay? And he had one of his little unpaid interns out here. And he knew that the tower was perpendicular, right, to the ground. And he would take a stick and tilt it until he could see his unpaid intern down here. And that would give him an angle here. And so he knew that because, right, we've got reflexive property. Do you see it? Angle, side, angle there. He knew that whatever this angle was, if he used that same angle over here to see the ship, that the result would be that these 2 would be congruent. So he used angle, side, angle to make these 2 triangles congruent, and then he knew that corresponding parts of congruent triangles are congruent. because however far away the unpaid intern is, if these two angles up top are congruent, however far away you are over here, then you know that the ship is the same distance because corresponding parts are congruent. So let's look at our proof. We know that we have right angles because all good buildings are built perpendicular to the ground. And we know that our top angles are congruent. And we want to get these two bottom segments to be equal so that we know how far the ship is out in the bay. Well, let's look at what we did. Well, we know that those top angles are congruent. So this is our top angle. And here is our side in the middle, right? It's just reflexive property of congruence. And we know that the bottom angles here are right angles. That's given, or sometimes we use definition of perpendicular when we're given perpendicular, right? And then we make those angles congruent because we know that all right angles are congruent. And that allows us to make our triangles congruent. Once our triangles are congruent, we know that all corresponding sides and angles are congruent, because now we have congruent polygons. We did that through our angle side angle, and that lets us say that these two previously unmarked segments are congruent because corresponding parts of congruent triangles are congruent. So math is useful. Geometry is useful. Understanding congruent triangles is useful. And this is an excellent proof. We should write good example here. So you can return to this one and see this proof for reference, especially with the right angle stuff. It'll help you get your right angle statements correct. All right, that's it for this lesson. Go ahead and go to the back and try the next two proofs. And I will do them too and see you in a few minutes. Okay, the first proof here was pretty straightforward. I redrew my diagram. We have a first set of sides here is given, the second set of sides is given, and hopefully you immediately saw the vertical angles in there in the middle. And so we see that we're going to make these triangles congruent by side angle side. And so then I write my congruence statement, and I just started here at B and went up side 1 to my angle and then up side 2. So I did the same thing on the other side. Side 1 to side 2 is DAE. Now, what am I trying to prove? I'm trying to prove that angle C here and angle E are congruent. We have no way of marking them congruent, but now that we have used side angle side to make our triangles congruent, we know that all parts, corresponding parts of those triangles are congruent. So I look here and angle C is in the same position as angle E, so I can say they're congruent because corresponding parts of congruent triangles are congruent. So this was a really straightforward proof. You should have been able to do this. If not, come in and see me for help. So those are just right there, and then I made my triangles congruent. I got side angle side, made my triangles congruent, and then what I'm asked to prove is those angles are congruent by CPCTC. All right, you can pause the video and look over this one if you need to. Let's go to the second one here. We were given our diagram. I redrew it. I redrew mine standing upright just because that's how I think of the triangles. You can draw it sideways. It doesn't matter. As long as everything is labeled correctly, you're good. And so we have our first sides here, BA and CA, are given to us, and then immediately I saw reflexive there in the middle. So I have another side. And then here in our given says M, point M, is the midpoint of segment BC. So as soon as I see midpoint, I know that means two congruent segments. And who am I cutting in half? Segment BC. So I come down to my diagram and I find point M and segment BC, and it cuts segment BC in half, so I can mark those congruent. That's definition of midpoint. That means I can write a triangle congruent statement. I have side, 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 and make my triangles congruent. So I just started here at B, went up side 1, down side 2, BAM. Started here, side C, went up side 1, down side 2, CAM. So now my triangles are congruent. Now what am I trying to prove? I'm trying to prove these two angles, angle AMB, that's right here, and angle AMC. So I want those two angles to be congruent. I have no other way to mark them, except now I have congruent triangles. So let's check and see if they're in the appropriate positions. Let's see, I went A to M and over to B. And let's check this one, A to M over to C. Yes, they are in corresponding positions, so I can say that they are congruent. Now this one again is pretty straightforward, but this is why I have you break it up, do your define, explore, get all your ideas together, and now we're going to write our official proof here. So I know I need my first side. My first side is just given, that's easy. My second side was just reflexive property of congruence. That's easy. The third side, I know I'm using definition of midpoint, but don't forget that you need the information from the given. We need to say that point M is the midpoint of segment BC. That was given to us because that allows us to say that the segments are congruent by definition of midpoint. So this is why I have you break it up, because this side you also have to have the given so that you can have your congruent sides. So do your define, explore, and break it up and do one piece at a time for this very reason right here, because this side requires 2 steps. And then I wrote my triangle congruence by the SSS postulate, and my two angles, that doesn't say angle, it says triangle. My two angles are congruent because they are in corresponding positions, and corresponding parts of congruent triangles are congruent. My triangles are congruent, so the corresponding parts are congruent. Now, I really believe if you work through these carefully, right? This is not fast math. Geometry is a slow math. It is a thinking math. So you have to do your define, explore, mark everything, set it up. You know my thoughts on color. I think geometry is easier in color. And break it down piece by piece. And if you're having problems with proofs, please come get some help. And I hope you enjoy these. I think these will be kind of fun. There's nothing new here. We are simply putting all of the first half of chapter 4 together and using it in one. So your triangle congruence from 4.2 and 4.3, and the definition of congruent polygons from 4.1, which we are calling CPCTC. Corresponding parts of congruent triangles are congruent. So do your define, explore, and enjoy your triangle congruence.